Big data is a buzzword. You hear it all the time. Everyone seems to know what it means, but it's hard to nail down a definition. Essentially, big data is a data set that's far bigger than anything that can be handled by traditional spreadsheet software. We're talking about so much data that it's very difficult to wrap our heads around it. Now, as technology improves, it's becoming easier and easier to make sense of these really big data sets. In this lesson, we'll discuss how companies can use business intelligence to transform this data into a usable asset that adds value to the organization. Now, people often describe big data using the 4 V's. Volume is the easiest to understand. Big data is big. We're easily talking about millions or billions of observations. Velocity refers to how fast data are generated and analyzed. For instance, every day, the New York Stock Exchange captures more than a terabyte of trade information. It's important that companies have the capabilities to organize and use this data as quickly as possible. Variety refers to the many different forms the data can take. It goes far beyond numbers typed into spreadsheets. Data come from emails, videos, social media posts, almost anything you can think of. Finally, veracity refers to the quality of data. It's difficult to make sense of all the data around us, and poor quality data will keep us from drawing meaningful conclusions that will provide value to the company. Now, the opportunities for using big data are incredible. Hospitals can use big data to better understand how pharmaceuticals interact with one another and how they affect millions of their patients. Scientists can use big data to better understand the billions of base pairs of DNA that humans have, or how environmental factors influence weather and climate patterns. Companies can use big data to understand customers' buying preferences, or how customers react to advertising. But all of these opportunities depend on data being usable. So on one end of the, we'll call it a usability spectrum, we have structured data. Structured data is data that has been placed into a relational database. It is often structured like spreadsheets with columns and rows, and it can be quickly queried using SQL to search for answers. Unstructured data is on the opposite end of the spectrum. It's not easily searchable. It's often text-based, or it comes from pictures or videos. This type of data is very difficult to structure in a searchable way. And somewhere in the middle, we have semi-structured. Semi-structured data is data that has some features that allow for classification and grouping, but it does not have a formal structure like we would see in a relational database. All right. Now, I want you to understand that there's a natural progression from data to action. Data by itself has little or no value. Data that can be organized in such a way that it can answer questions like who, what, when, where, or how is considered information. Knowledge requires human understanding. Insight or judgment is an even more subjective concept in which a person delves into their knowledge base to make connections or see patterns that are not readily apparent. Now, once a company sees this insight, they can take actions to add value to the firm. But the question is, how do we get from raw data that's not worth very much to us to action that can add value to the firm? Well, that's the purpose of business intelligence. Business intelligence is the collection of applications, tools, and best practices that transform data into actionable information that we can use to improve performance. It involves tools that help make our unstructured data a little more structured so that we can use it. It's all the tools we have to help analyze data and patterns. Let's walk through an example. Let's assume that we run a grocery store. Now, many grocery stores have security cameras throughout the store. Why? It's to be a deterrent. It's to keep people from stealing inventory. But let's think about the enormous amount of data that those cameras create on a daily basis. 24/7 security cameras all over the store. It's a lot of data. What can we do with that data? Traditionally, not much. If there's a theft that occurs, we could review the tapes and see some kind of a blob that we would then put on the 10 o'clock news to help people, so that people would help us identify the blob and apprehend the criminal. But other than that, these cameras don't provide very much information. It's just raw data that's not worth much. But what if we could use tools to make that unstructured data usable? Let's assume that we replace our cameras with some high-definition cameras, right? Better data means we can do more with it. But even if we're not going to do that, this information can still be useful. What if we use software to recognize that moving objects in our cameras on these screens are individuals? Now we can start to understand how people move around the store. We can see where they stop within the store and for how long. We can start to understand patterns. Then we can start trying to gain insight out of those patterns. Now let's suppose I have a theory. Suppose there's a relationship between price elasticity and the amount of time that a customer spends in front of a display in the store. If they stop for a second, purchase an item, and then move on, perhaps that means that they are not price sensitive to that item, right? So that we can raise prices and increase profits. If they spend more time at the display, perhaps that means that they're not sure whether the cost justifies, the purchase. Maybe they're more price sensitive to that item, and if we lower prices, maybe we make more money. This may be a good insight. It can help us take an action and see how the store's performance changes. Perhaps one day, if I have good cameras, we compare that feed, right, that data from those videos with facial recognition software, and I can base advertising strategies on individuals. Now, there are still many challenges to analyzing big data. Perhaps the biggest is trying to get machines to think like humans. How do you mimic the type of thinking that leads to human insight? In addition, as companies collect more and more data on customers, there are a lot of privacy concerns. People don't like to think about companies tracking their every move. So a company's data can be an extremely valuable asset, so long as it can be transformed from raw data to an actionable item. It's easier said than done. Much of the data we have is unstructured and difficult to use. Still, as we've seen with the advent of self-driving vehicles and other recent technologies, companies can make sense of all sorts of data using business intelligence.